We present a spreadsheet tool for using and analyzing hierarchical data such as JSON data. In this video, I will demonstrate how our tool lets users easily reshape a hierarchical JSON document and calculate summaries using spreadsheet languages and interaction techniques. Here, I will explore two JSON files about the Chi 15 conference. I first load a file about all the conference papers in the left pane. I'm interested to know which institution has the most papers. I start by using drag and drop to extract fields that I think are relevant to this task. I extract the paper titles, the author names, and institutions. In our system, how a column is shown always depends on the columns to its left. If the left columns come from an ancestor field like here, the system visualizes the data as nested tables to put the descendants in the same row with their ancestor. If the left column comes from a sibling field, the system copies the left column structure to this column and puts the siblings in the same row. Now, when I change the column order to let the author data be at the beginning of the spreadsheet, you see that the system reshapes the data. Now for column C, the system found that the data in its left column came from a descendant field, so the system repeats the ancestor value to again let the ancestor and descendants be in the same row. Using this feature, the user can easily regroup the data by any fields in the JSON file. To find out which institution has the most paper, I will group the data by institutions. I do this by moving institutions to column A, and then right-click and select Group Column B to C by column A. The system merges rows that have the same value in A and put B and C into nested tables. I can see that column B has many repetitive values because a paper can have many authors from the same institution. So I group the data again using B to merge those values. I insert a new column here to store the number of papers for each institution. I use a count function to count the number of papers for the first institution, and then I use autofill to fill in the rest of the rows. Our tool currently shows the first 50 rows of the data and hides the rest of the rows, but all the calculations such as sorting, filtering, and autofill are done on the entire data set. Our paper has more details on that. I sort the data to bring the institution that has the most papers to the top. Here's my answer. Now I will do a second task, which is to create a conference schedule that shows for each time slot the session that has the most award papers plus papers that have crowdsourcing as one of its keywords. I start with a clean spreadsheet, load a paper file and a session file. From the session file, I extract each session's day, time, title, and submissions, which are papers in their IDs, to the spreadsheet. Then from the paper file, I extract each paper's ID, title, award, and keywords. You see that there are gray lines here separating the two tables because they are not from the same file. To join the two tables, I select the common columns, which are the paper IDs, right-click and choose the join option. You can see that the system merges the tables into one. Now for each paper in the session, I have their title, award information, and keywords connected to the right. I will insert a new column here and uses this function to compute if the paper is an award paper or a paper that has at least one keyword being crowdsourcing. I drag down to fill in the value for all papers. Then I filter to view only papers that have yes for this value. I insert a new column next to the session title to calculate the number of yes papers in each session. Again, I use a count function and then I autofill. Okay, now let me group the data by session, day, and time so I can view it better. Finally, I use sorting and filtering to get the session that has the highest paper count for each time slot. And here is my schedule. In our user study, we recruited experienced Excel users and programmers to use Excel and programming to do similar tasks. On average, participants using our tool finished the task nearly 2 times faster than participants using Excel and programming. For details, please read our paper.